Hi, this is Otto with ORATS. Volatility surfaces are often discussed but rarely explained in a way that is actually useful. Here's the core idea. Options are not priced with one volatility. They are priced across time and across strike. That entire pricing structure is called the volatility surface. Everything else is visualization. When someone says a stock has implied volatility of 25%, that number is incomplete. Which expiration? Which strike? At the money or out of the money? Every option on the same underlying has its own implied volatility. Near-term options trade differently than long-dated options. Puts trade differently than calls. The volatility surface is how the market prices all of that at the same time. Professionals simplify the surface by breaking it into two parts: term structure and strike structure. Let's start with term structure. Term structure describes how implied volatility changes across time. In normal markets, short-dated options trade at lower volatility than longer-dated options. That upward slope is commonly called contango. It reflects a simple idea. More time means more uncertainty. When markets become stressed, that slope can invert. Short-term volatility rises above long-term volatility. This is backwardation. Backwardation tells you the market is pricing risk right now. ORATS evaluates term structure by focusing on standardized time horizons. Short-dated implied volatility, typically under 45 days, reacts first and most aggressively to changes in sentiment. That is where information shows up first. Now let's look at strike structure. Strike structure describes how implied volatility changes across risk. This is often called skew. In equity options, lower strikes usually carry higher implied volatility than higher strikes. Investors pay more for downside protection. Most platforms show skew using strike price on the horizontal axis. That makes comparison difficult. A $100 strike is at the money for one stock and deep in the money for another. ORATS solves this by using delta instead of price. A 25 delta put represents similar downside exposure regardless of the underlying. This allows skew to be compared across stocks, sectors, and history. Once skew is normalized, it can be measured. The primary metric is slope. Slope measures how quickly implied volatility rises as you move toward lower deltas. A steeper slope means downside protection is expensive. A flatter slope means downside protection is cheaper. Slope matters most in context. ORATS places slope in historical context using slope percentile. This shows where today's slope ranks relative to its own history. For example, if slope is in the 90th percentile, downside protection is more expensive than in 90% of historical observations, even if overall implied volatility appears average. ORATS also measures curvature, sometimes called derivative. This captures how much the skew bends at the wings. For most traders, slope matters more than curvature. Slope is the first-order effect. Curvature is secondary. The goal is not prediction. The volatility surface does not forecast direction. It provides context. It shows how the market is pricing risk across time and across strike. That context is what allows traders to identify value. The volatility surface is not a chart. It's a framework. If you want to go even deeper, you can explore volatility surfaces, term structure, and skew directly at ORATS.com. You can also find detailed articles and walkthroughs on the ORATS blog that expand on everything covered here.